In this segment, we're going to talk about going about naming aldehydes and ketones. So in order to name aldehydes and ketones, what you want to do is, much like with naming other types of molecules, you need to find the longest carbon chain. And unlike when we were doing things like naming alkanes and alkenes, the longest carbon chain that you pick here has to include the carbon that is part of the aldehyde or ketone group. And as a reminder, the aldehyde group of a molecule will always be found at one end of the molecule or the other. It's going to be a carbonyl group that is directly bonded to a hydrogen, as I've drawn in green there. A ketone group is going to be a carbonyl group that is not at the very end of the molecule, but instead is a carbonyl group that is directly bonded to two carbon atoms, much like I've drawn in green there on the screen. So that's what you're looking for if you're trying to recognize an aldehyde or ketone group, these two different types of carbonyl containing groups. And so your longest carbon chain that you pick out in the molecule absolutely has to include the aldehyde group or the ketone group. The parent name of a molecule that contains an aldehyde group is going to have the suffix al to remind us that that molecule is an aldehyde. So for example, pentanal would be a 5-carbon aldehyde. On the other hand, if we're talking about a ketone, what you'll want to do is make the parent name of the ketone molecule have the suffix one. So pentanone or hexanone or things like that, going back to our nomenclature based on the number of carbons in the longest carbon chain. With the aldehyde, there's no need to specify what carbon atom has the aldehyde group because that will always be carbon number 1 of the chain. So with the aldehyde group, the aldehyde is always at carbon number 1. That's where you're going to start numbering your carbon chain. On the other hand, with the ketone, you do need to specify in the parent name where the ketone group is located in the longest carbon chain. So for example, 2-hexanone would indicate that your carbonyl group is at carbon 2 of the 6-carbon chain. So let's take a look at the example problem shown here in blue. And we're going to try to go about naming this molecule. So we need to find our longest carbon chain that includes our carbonyl group of our ketone in this case. And if you take a look at the molecule, you might see that the longest carbon chain overall has a total of 7 carbons, highlighted there in yellow. But that's not the one we want to go for. We have to go for the one that contains the carbonyl group. So what we're going to go with is what I'm outlining in red here, because that is our absolute longest carbon chain that contains the carbonyl group. So we've outlined that in red. Then we're going to go in and number it starting from the end closer to the carbonyl group. So we go ahead and number that. We come up with a 6-carbon chain. So that means that our parent name here, since our ketone group is at carbon number 2, is going to be 2-hexanone. And then much like we've done with all of the different types of molecules that we've named, we need to go in and specify the names of the branches. And we only have 2 branches here. We have the yellow branch, which has 3 carbons and is just a chain. So it's going to be a purple branch. And then at carbon number 4 there, we have the methyl branch coming off. So we plug those in alphabetical order, as hopefully you are used to doing by now. And we'll go ahead and put those in here at the front of the name. So it's going to be 4-methyl, 3-propyl, 2-hexanone as the full name for this. Let's take a look at another example problem. We're going to kick up the intensity just a little bit here. So we're going to start with a molecule that has both an aldehyde group and a ketone group within the same molecule here as our example problem. So in this example problem, we have an aldehyde group and a ketone group. So we need to talk about how we go about dealing with that. And in order to go about dealing with that, we need to talk about how we prioritize where we start numbering within the carbon chain and whether an aldehyde group or a ketone group is higher ranking for going about doing that. So when we talk about the rankings, and we're not talking about the rankings here for assigning R and S chirality, we're talking about the rankings for coming up with how to number the longest carbon chain, where to start numbering that. For coming up with the ranking to name and find the longest carbon chain, we're going to go with the priority order here for ranking or naming the longest carbon chain. That when you're coming up with the longest carbon chain, you want to start numbering from the end closer to the carboxylic acid group if there is one present. So I'm abbreviating carboxylic acid there as Ca. So that's going to be our highest ranking when we decide which end of the carbon chain to number from. Second highest in this hierarchy is going to be the aldehyde. Third highest ranking is going to be the ketone, which outranks hydroxy groups of alcohols, outranks amino groups, and a variety of other types of groups such as halogens, alkyl groups, alkenes, etc. So when we start numbering and deciding how to go about numbering and naming our longest carbon chain, it's going to be super important that we keep in mind, particularly for this chapter, that aldehyde outranks ketone. So in the case of the example problem here, we have both an aldehyde and a ketone group, and so we're going to start numbering from the end closer to the aldehyde. So we're going to start here at the left with the aldehyde group being carbon number 1. We're going to work our way through that longest carbon chain that also includes our ketone group. We'll go ahead back in and we'll number this, starting from the aldehyde carbon being carbon number 1. And that leaves us with a 7 carbon chain in total. So we'll go ahead and plug in our parent name here of heptane. And specifically, it's going to be heptanal to indicate to us that it is an aldehyde molecule. No need to specify one heptanal because the aldehyde group will be at carbon number 1. And then we go ahead in and specify our branches. And this is where a new point comes into play, and that is how do we deal with the fact that we have a carbonyl group here at carbon number 6. The way that we deal with that, specifying it as a branch, is we refer to it as an oxo branch. So we're going to specify this here as a 6-oxo branch since it's coming off of carbon number 6 of the chain. So we would then plugging this all together and putting the oxo in alphabetical order with our 2 methyl groups at carbon 4 and carbon 5. We would refer to this as 4,5-dimethyl. 6-oxo to specify our carbonyl group of our ketone, heptanal. And the oxoheptanal can appear as one word there, even though I left a little gap because I wrote a little bit smaller than I intended to there. So that's going to be the full name of this molecule with the exception of the stereochemistry. And you'll see that we have a couple of chiral centers there, so we do need to go in and specify those chiral centers as R or S and indicate where they're located. So to do that, we're going to use the tools that we've learned previously. So I'll go ahead and fill in my parentheses here at the front of the name, 4 and 5. And then we're going to go ahead and determine whether each of those 2 chiral centers is an R chiral center or an S chiral center. So let's go ahead and rank the groups relative to chiral carbon number 4 here, which I have put a star on. So we need to rank our groups that are bonded there, and if you go in and go through the ranking rules, you're going to see that our first ranked group is that carbon atom that sits to the right. Second highest ranked group is the one to the left. Third highest is that methyl group. And fourth, of course, is the hydrogen, which is pointed away from us. So we go ahead and draw our circle from 1 to 2 to 3 ranking. That's going to take us clockwise. And so therefore, chiral center number 4 is an R chiral center. We come ahead and do the same exercise here for carbon number 5. And I'm going to first try to erase a little bit of the info here surrounding the chirality assignment at carbon 4, so there's not so much noise around carbon number 5, so that we can see where we're making the ranking assignment here. Go ahead and clean up the molecule just a little bit. And then we'll get onward with going about assigning the chirality at chiral carbon number 5. So So we have that chiral carbon right there. And when we go through the ranking order for the groups bonded to that, of course, we come right over here to our oxo group, our carbonyl group, and that's going to be the highest ranking group there. Second highest ranking is going to be the carbon of the carbon chain. Third highest ranking is going to be that methyl group. So much like we did at the chiral carbon at carbon 4, we go about our ranking from 1 to 2 to 3. That takes us counterclockwise, but remember that the hydrogen is pointed toward us rather than away from us, and so that means that this is going to be an R chiral center as well, just like carbon 4 was. So it's going to be our full name of this particular molecule. By the way, you might be wondering, what if we had a carboxylic acid molecule that also had an aldehyde group in it? Since we see here that carboxylic acids rank higher than aldehydes in deciding how to name the longest carbon chain and where to start at, if we had a molecule that had a carboxylic acid functional group and an aldehyde group, what would happen is that the parent name then would go along with the carboxylic acid name. And the aldehyde would be a branch. And if the aldehyde is a branch, the aldehyde branch name is also going to use the prefix oxo, just like a ketone group uses the prefix oxo. So both aldehydes and ketones, if those have to be specified as a branch because there's a higher ranking group in the molecule as well, then the prefix for that is going to be oxo. So if you name aldehyde as or ketone as a branch, you're going to specify it as oxo. And you'll put that at the front of the name in alphabetical order with a number indicating exactly where that oxo branch comes off. Another common situation that we run into with aldehyde molecules is the situation where we have a cyclic molecule with an aldehyde branch coming off a one carbon aldehyde branch. And in the case of a one carbon aldehyde branch coming off, we refer to that molecule as having a formal group, or we can refer to it as a carbaldehyde molecule. So let's do an example of that type of problem. So an example would be this 6-carbon ring. Notice it's not an aromatic ring, it's just a cyclohexane ring. And we have the aldehyde group directly bonded to it. So the name for this molecule would just be cyclohexane carbaldehyde as one acceptable name for that. Or alternatively, we can refer to that group as being a formal branch, F-O-R-M-Y-L. So the group is referred to as a formal group. So we could also refer to this molecule by the name formal cyclohexane. So if we're referring to an aldehyde group as a branch, where that branch has a 1-carbon chain coming off of the parent, the group is referred to as a formal group. As a reminder, we did talk about one aromatic molecule which had an aldehyde group, and that molecule had this structure, and we referred to it as benzaldehyde. A very uncommon but acceptable name for this molecule would also be formal benzene, because that's referring to the fact that there's a formal group branched off of a benzene ring. But most commonly, you will see this molecule referred to simply as benzaldehyde rather than anything else. Another aromatic molecule that you should be familiar with, that rather than having an aldehyde group bonded directly to the aromatic ring, has a 2-carbon ketone group bonded to the aromatic ring, is this structure, which we refer to as acetophenone. And that ONE suffix there should designate to you that this molecule is a ketone, and the aceto portion of that group is going to clue you in that we have a 2-carbon chain there coming off of the ring, because when we think of acetyl groups were a 2-carbon chain with a carbonyl on it. So acetophenone is an aromatic ring, hence the phene part of that name. and the ONE indicating a ketone, aceto helping emphasize that it is a 2-carbon ketone group hanging out there. So that's the basics of going about naming these molecules for IUPAC.